All right, I think since everybody's here, I think we got 5 seconds left, but anyways, we'll start promptly. So we're gonna kick off this first half hour hearing from Lika. You guys heard from her during the remote portion, the remote week, but she's gonna talk to you again in person, which is always a nice thing. And then after that, we are going to go through the posters, advertisements where you get one conjunction and one sentence to tell us what your poster is about to get people excited about that. But we'll start that at 1:30. So we're going to start with Lika. Jump up here and go ahead. Do you want this mic?
Do I need it?
They want you to use the mic because we're recording.
No, I'm good.
You're going to stand at that mic? Okay. Go. Okay.
Good afternoon. I think already did a little bit of introduction. Lika Guhathakurta. I guess I am the longest standing heliophysicist at NASA headquarters. I started there in 1998. Stereo was my first mission. And you can still see, people who are stereo PIs are still giving me hard time because they decided to do level 1, level 2 differently. So I'm still catching flack for everything I've ever done in my life. And after stereo, my goal was that's such an amazing mission that I was going to come back and do my science. So I am an astrophysicist by training. In my thesis work, actually, I tried to connect the corona and the heliosphere. So these communities didn't talk to each other, believe it or not. And I'm only talking about what, 1999, 2000, 2001, that time frame. In fact, I met Christina when she was still a graduate student, 1994, 93, 94. And that was the first time, I think it was my attempt to bring 2 missions. One of them, a very big one, Ulysses, that you're familiar with, I'm sure, especially people who are doing solar wind analysis that orbited actually around the sun, pole to pole, but very far away from the sun. And that was our first glimpse into the world of in situ data coming from both from the poles and equator. But this was a flyby, so it's not like you are there and taking observation. So a lot of the images that you have seen of the polar passage from Ulysses are just, again, single point measurements over an entire solar cycle. So so we were trying to combine in those years, the mid-90s, Ulysses, and I was part of this experiment called Spartan 201. And this is before going to NASA headquarters. I was at Goddard Space Flight Center doing my research, and we were flying 2 coronagraphs. One is a white light coronagraph. The other one was ultraviolet coronal spectrometer, which was part of known as UVCS on the SOHO mission. And so for me, actually, that was the first workshop, as far as I know, we created between these 2 communities, sort of the heliospheric in situ community and the remote sensing solar community, even though they are driven by the same object. And that's where I first met Christina as a graduate student finishing soon, and continued kind of, this relationship. So so I came to headquarters, did stereo. I was going to come back to Goddard to do science. But during that time, I think we developed a concept called Living with the Star program. Beautiful name for a program. The name was given by one of my colleagues, Dr. Bill Wagner, who is no more. And he's the one who has essentially dragged me to headquarters. And at that point, I had to make a choice. Do I go back to my own personal research, or could I do something, fundamentally radical in the way we are doing science in stovepipe manner, and stay at headquarters? And I decided to stay at headquarters, become the program scientist for the program, Living with the Star. And I have to say, do I miss not having done all the science I wanted to do? When I come here and listen to the cool science ideas, I still get very excited. But I think my contribution would have been less if I had not stayed on with the program and give it, each individual would have taken it in different direction. And I kind of shepherded in what you see today in many of the missions in Living with a Star program. Solar Dynamics Observatory, Radiation Belt Storm Probes, also known as Van Allen probes, Parker Solar Probe, Solar Orbiter Collaboration. These are all missions that happened under me. And then, I took a break from NASA headquarters, went to NASA Ames Research Center in 2016, 2017, and I was there till the COVID started. And I just kind of started in an entirely new sort of domain almost, and that is utilizing artificial intelligence, machine learning to look at our data in new ways. And I'm really super excited by what we can do and what we are already doing. So that's my story in a nutshell. And I am here because, I've been there as a bureaucrat, as a scientist, as an outreach person. I have created planetarium shows and things like that as well. I'm ready to answer some questions that you might have of me. And if you can bring up the next slide, I'll just keep it there, just for reminding all of you. So this is fondly called the Heliophysics Systems Observatory. This is the assortment of spacecraft we have, all the way from the very close to the sun to the outer edges of the solar system, like Voyager. And we have 19 operating missions with 26 spacecraft. And we use this data. You have been talking about data all this time. And we are various assortment of data. But if you think that, oh my God, this is a lot of spacecraft, we should be able to answer all the questions. Well, you already know that the answer is very far from the truth. There's the distance between sun and earth is 93 million miles. These are not even like one buoy in our ocean when you compare the vastness of space. So, okay.
All right. Lika's seen this field from just about every angle, so feel free to ask her all kinds of questions. And I'm going to actually throw.
Yeah, this is something that I've heard other people talk about a bit. So in terms of like spacecraft missions, there's no really like new place to go. We've been very close to the sun. And I mean, further away doesn't really make that much sense. So what are like the new missions going to be looking like in the next few years for heliophysics? If you can't send up updated versions of the old instruments, because some person said NASA doesn't like to do that. We've already been very close to the Parker Solar Probe. Getting closer might be a bit more complicated. So where is that going to go going forward?
So one chart I didn't include here is that right now in the US, and I know there's a lot of international students here, we have an active process called decadal survey planning going on. So generally NASA does not dictate, what missions we are going to do. We essentially work with the community, take feedback, facilitate that. We are steward of taxpayer money. It's a federal agency. So we are awaiting that report. That's going to be very important. But I want to put a new spin on the word new. New vantage point is important, right? And if you think of vantage point, we have not been to the poles of the sun with remote sensing observations. We really, if you think of sun as one of those biggest driver in our solar system, then we do not really know what the magnetic field of the sun is at the poles. That is a very fundamental question. So earlier you guys were asking questions about, calibration, or how do we know this is, what assumptions did we make? We are always making a lot of assumptions. We really don't know the true magnetic field in the poles. That is a vantage point we would like to go to. We would like to really, when we talk about space weather prediction, the entire country, entire world is very much keyed in on that. Then, stereo gave us a 360 view with 2 spacecraft. It was amazing. It gave us a 3-dimensional view of solar storms, but it continues to give us a 360 perspective, because stereo spacecraft is essentially in an orbit that is very similar to Earth, going around the sun. And in fact, one of them is coming back to us. Stereo spacecraft, 2 of them launched in 2006. August 23rd this year, Stereo A spacecraft is coming back to the same area where it was launched from, and we lost contact with Stereo B in 2014. So having multiple sort of observatory instrumented with new generation of instruments, that's the other thing. What are the kind of measurements we want to make? We haven't really looked at the infrared part of the solar spectrum. If you think of what the astrophysicists have done, they have revolutionized astrophysics with infrared spectrum. Infrared can give us better diagnostic on magnetic field. At the end of the day, it's the solar magnetic field that is driving everything. That's where lots of the interesting energetics are being created. So we don't have a good handle on that. So you can take it in that way. You can think of constellation around the sun, constellation around our planet Earth. Just like we are going to view or want to view the poles of the sun, we also want to view poles of our own planet. But this is, with imaging instruments, and we have samples of things we have done, but we could do it better. We could surround our planet with, constellation of satellite to actually look at what the ionosphere is doing, real-time measurements. Something happens on the sun, we know generally how fast it's traveling, what are the impacts. So you heard Mark talk about decoupling, detangling spatial and temporal components. So the questions are endless almost. And the ideas of missions is just what we need to propose based on science. Thank you for the question.
Yeah, to think about is, not only going to new vantage points or developing constellations, so you have a 360 4-pi sun type of view. You could also start thinking about technology advancements. So a solar sail, you could imagine sitting in a non-Keplerian orbit, always over the North Pole of the Earth. So you would have 24/7 auroral imaging, where everything else was, you swept by and you have to be at apogee when the substorm went off or whatever. So you could start thinking about, what do we have? And now we also have potentially 30,000 LEO satellites that are commercial. What if they had some space weather instruments on it? What would we do with 30,000 data points of the radiation belt or whatever it is, right? So,
amazing science.
yeah, so it's not only where do we need to go, but how can we do things different?
An hour back, you said SDO is the biggest data producer that we have right now. The predecessor of SDO, SOHO, has been in commission for 25+ years now. Some of the instruments stopped working after 2010. So SDO was technically the successor of SOHO.
But definitely it's a successor, but not everything, right? So SOHO is a mission kind of like what India is doing with Aditya. So it had a full suite of remote sensing observations like spectrometer, coronagraph, or helioseismology, but it also had in situ package, which is all the fields and particles and plasma parameter measurements. So SOHO was a much bigger platform in scope. So many of the instruments, so for example, the helioseismology instrument MDI, we decommissioned it after SDO was launched because HMI on SDO is much better. So you do calibration, stop it. We are still actively monitoring the spacecraft and taking the coronal observation. That is kind of really, really important. SOHO is a NASA ISA mission. So Europeans are still gathering data from some of their instruments. We are primarily using SOHO coronagraph like as an infrastructure measurement, so that we continuously get those data. And radio, absolutely. Radio, wherever it is, it's continuously giving us data in many missions.
Just to end with the actual question that I really had was, is there any talks of having a successor to SDO, or do we really not need one right now?
So, I don't know how to answer that question. Our missions last a long time, keeping my fingers crossed. We need SDO right now because we have nothing like that capability right now. And that's why I mentioned the decadal survey. That is a process by which we kind of figure out what our next strategic mission might be. So even though we are not thinking, there isn't anything in the pipeline right now as a strategic mission, but we have few solar missions like Punch, that is actually going to give us a view of the in-between region where stereo kind of left off, and Punch begins, taking images with 4 spacecraft of the heliosphere and connecting that to L1 observations. So there's continuous sort of progress and imagining of where can we really add tremendous value within the budget constraints.
Thank you.
Okay, so you told us heliophysics is a made-up word. And everybody here is really passionate about heliophysics. That's why we're here. But I don't think heliophysics is as attractive to the taxpayers as like planetary sciences or, black holes and astrophysics. It's kind of harder to sell. And so, and also I think that our cut of the budget has suffered because of that. So how can we help talk about heliophysics and its importance? And as Fran Bagenal would say, how do we make heliophysics sexy to the rest of the world?
So give me 10 minutes so that I can show the last few charts to answer the kind of question for heliophysics. Can we scroll through quickly? Let's see what we have. These are the set of, you can see these. I have these charts. You can take a look at this. And the next one, please. These are our various program elements, might be important for you to see if you're ever proposing to NASA. Not going to talk about it. Next, please. This is our open platform for science. You heard a lot about this. This is very important. Our data and the way we do science and the way we make it available to community is going to change. And it's not NASA alone. It is the entire federal agency going after this. Next, please. So this is the heliophysics big year, and I have several charts here. I won't go through this right now, but citizen science using kind of opportunities like annular eclipse, total solar eclipse, any other event to catalyze the community to describe our science in common layperson's terminology. Scientists get very sort of jargonish in their description of science. Those are things we still have to do. I think heliophysics simply replaced our stovepipe disciplines and integrated that, which is doing much better than the disciplines in itself did. So we've made tremendous advancement. Our budget has gone up, but astrophysics and planetary are of a different scale. I am fascinated by them. Planetary is sort of destination driven. We are going to a new place. So you know how exciting that is. And astrophysics is almost spiritual when you kind of use the binary scale and convert them into real image, because that's not what we are taking, but ordinary people don't know, right? It is very deep. You're talking about the universe. So I don't know whether these are fair comparison. I'm kind of relatively happy with the state of heliophysics, and we absolutely need the community's help to really communicate why it is important. So if you think of, you didn't bring up earth science. So heliophysics in a nutshell is a combination, it's hybrid basically, between astrophysics and meteorology. And that's what makes it very difficult to communicate. So the geospace side is more kind of meteorology like science. The solar side is more like astrophysics. We are bringing in magnetism, a new force that just makes our science incredibly rich and difficult, but we have to communicate that. And that's why there are these gaps in communication. That's why we have this summer school, so that you all learn each other's vocabulary, so that you can communicate with one coherent message. So the future of it, like in any field, depends on the future generation. And that's you. Back to you.
Oh, gosh. I'm not gonna.
My own personal bias is, I think, astrophysics really benefits from these amazing pictures, right? So you put up James Webb or the Hubble or whatever, and you get these pictures out and everybody can appreciate them. They're like, oh, I'm imaging the cosmos and all this stuff, amazing stuff that I've heard in, science fictions and black holes and all that kind of stuff. And for a long time, our data was mostly like, my data, which is all line plots, which is really hard to make very exciting. I look at it and I go, oh, wow. And everybody else goes, squiggles. Yeah, okay. But I think SDO has been huge on that, right? So SDO was one of those things that started really pushed this effort of making these amazing pictures, not just for science, and this is gonna sound like I'm undercutting, but it's not true, is also making it available to the layperson, right? Putting out these pictures, sending it to the press, saying this is like really cool. And I would say that over the last special couple of years, well, 10 years, say, the amount of press that solar physics, heliophysics gets has gone way up, right? This discussions about solar flares and solar geomagnetic storms and, and those kind of things. And, Parker has put in a lot of effort to do that, kind of explain to people why it's exciting. Like, we built the fastest spacecraft ever, right? And those kind of things that, we may not consider them integral to our science, but they're integral in terms of generating excitement with people. And I think we need to sometimes, step back a little bit and say, what is exciting besides the science, or that enables the science, and, communicate that kind of stuff. And I think that doesn't help the, wow, all these arms going up. So that's just my person.
I just want to add on what Christina, you were saying, because how the interest has gone up, especially like post-COVID times. I'm from Alberta, and like we see aurora all the time. But pre-COVID, I don't know how many people would have gone just to see an aurora, and how many people are interested in it. But during the COVID times, you could not go out, you could not travel. So the only thing they could do is if there's an aurora, go to the national park, and people were just really looking for the predictions. And I know even the CBC News and all these news they'll be having, oh, we're going to have aurora today. I mean, maybe it's going to to the lower lads and you can see it. And people were so interested in it. And I remember there was an event, I don't remember which, I think it was in 2021. And so there's a national park, which is just 20 minutes drive from where I live, Edmonton. And so the Parks Canada people were saying that they saw more than 2,000 visitors at midnight, coming with their kids just to see aurora. So I think it has gone up, and it also depends on how you advertise it, right? So I think people are just really crazy about it. They didn't know really what we are learning, and also about the Starlink event. They started to read more about that only when it happened. So no one never knew, okay, what space weather, is it really important? So I think, yeah, it is getting important. It's coming up. So.
And there is a lot more from there. If you look at airplanes, what goes on, if you're doing EVA, if there are, secondary events causing malfunction of electronics on these full body, big hull airplanes, it's endless. So space weather doesn't happen just during solar max. Space weather happens throughout the solar cycle, throughout whatever the sun is doing. but the impacts are different. So we have to actually, so I'll give you another, actually, these are all wonderful to hear. And so the charts that I have, and you can maybe slowly kind of show the charts, and I don't want to talk to it, but I want those recorded, and I want you to have access to it because there are important links and information there. Citizen science is a great concept when it comes to Aurora. We have a program called Aurora Soros, trying to kind of capture this information. I lost thread of what I was going to say. Never mind, good. Someone else gets a chance. Well, this is so now we have two big events coming up. One is the annular eclipse, and right there, total solar eclipse. And that's happening 14th October, 2023, right around the corner. The other, America is so uniquely lucky, my goodness. We had a total solar eclipse coast to coast in 2017. In 2024, we have another one north to south. And this is going over a population that's 10 times more the population in the path of totality during the east to west crossing. So a lot more people are going to see this. Our social media skills have really accelerated. So social media, you can use it for good or bad, but if you use it for good, you have excited and actually provided direct knowledge to people. So when we think about the sun, we have to think about what the sun touches, and it's just everything. And you have to peel away those connections. Oh, yes, yes. Picture tent.
So I guess my general kind of question is like, how is the communication, do you feel, between the heliophysics community and the planetary community? Because sometimes I feel like I'm in the middle. Sometimes I'm told I'm heliophysics. Sometimes I'm told I'm, planetary. So like, and like when like spacecraft like Bepi Colombo goes to Mercury and it's in the solar wind most of the time, I feel like that's a more of a heliophysics thing. So like, is there good communication between the two kind of hard boxes that have been set?
Very, very good question. So all of you got this 4th volume of Heliophysics. You should take a look at that. That is actually, I call it comparative heliophysics, really learning from our system, learning about the sun as a star, learning about our geospace environment of our planet, and kind of the connection between the two, and extrapolating that to our terrestrial planets, to the Jupiter, Jovian, magnetosphere, you name it, and then exoplanet. We are already doing that. So I will say, and that book came out, I think, in 2013-14 timeframe. And so we were pushing this already through our program. And in the last 10 years, I think it's become much better. Is it a place where we are practicing interdisciplinary science? No, that is still kind of a lip service, but it is so much better than before. Absolutely so. So I feel good about seeing the progress in the time frame that I was gone, and I came back and I could see significant difference. But you will hear those comments. I mean, people will say, oh, you're a solar physicist. Oh, you are an ionospheric physicist, even inside our own community. So that just happens. People are people. Yeah, so the slides, yeah, we can go through the slides quickly. these are the kind of three things we are centered around, and this is exactly to address one of the questions that was asked, right? We sort of communicate our science utilizing eclipse, use the tools of citizen science, use our missions, existing missions, upcoming missions, and like latch on to that under the umbrella of heliophysics big year. Next, please. And these are the things I would like you to take a look at in greater detail, where you can participate, you can create your own, you can create little momentum around you, basically, to communicate the aspect of heliophysics science that you are really interested in. Next, please. These are all information about how to actually inform us at headquarters if you're doing something new and how we can help you. And of course, stay informed and communicate that to your own community. And this is the last one. So we are actually, this meeting ends, of course, the Heliophysics Summer School, but we have been doing Jack Eddy Symposium. We have a Jack Eddy Fellowship. He was kind of in our metric, in heliophysics metric. He was one of the first of its kind pioneer interdisciplinary scientists, who was the first one to connect the sun to climate. And for a while, he was thought of a quack, didn't get recognized until much later. So in order to honor him, we have Eddy Fellowship, and this is 4th Eddy Symposium. It's very cross-disciplinary. And, UCAR will support few students to travel. But if you have funding, you can come and join. It's going to be in Golden, Colorado. It was the end of October, beginning of November. Thank you. And yeah.
I live in San Antonio, Texas, and if any of you can make it, you can join me.
Okay.
It's in the path of totality. So I just wanted to ask you, what type of science experiments has NASA planned during the eclipses?
There are many, long time ago, eclipse sciences meant that because we can see the corona so cleanly and clearly to the very edge of the photosphere, that's the only time we can see it, not even with our satellite experiments, that ground-based observations looking at the corona was very important, whether white light, spectral, all of that. Today, we use our airborne asset, fly instruments on spacecraft to lengthen the time of the eclipse, to get faster cadence, to really avoid any cloud contamination. That is a big if for eclipses. In April of this year, I went to Australia for the total solar eclipse, where I was funding a team to fly a kite with an airborne spectrometer. Just imagine that. So you're developing new technology as a result too, but it's not just solar. So we do ionospheric measurements, radio measurements. We do ionoson measurements from the airplane. These are some of the activities that we have undertaken during this present eclipse. Because, eclipse kind of provides an occultation, right? It's on-off switch almost. The UV is gone. That energizes the ionosphere. So you can use models and you can do ground truth validation. So there's just lots of cool science you can do. And then there is, of course, terrestrial kind of impact.
Okay, and our fearless leader just walked in time. Fearful leader? Yeah. So the idea is we are now doing poster advertisements. Yes. Okay, are you going to be the arbiter of how many conjunctions people have violated?